Okay, in this example, it's kind of the reverse of what we're used to looking at. This is actually the graph of the derivative. Okay, so I'm going to write a couple of those rules again. Remember, if the derivative is positive, the original graph of f at x is increasing. If our derivative is negative or less than 0, the original graph is decreasing. And if the derivative is equal to 0, we have a critical point or a tangent or a changing point on our graph. So what that means, I want you guys to look at the graph we have here. If we're going left to right, it looks like this graph is decreasing. But what I want you guys to realize, this is much more important, okay, is that at this point, it's positive, okay? So our derivative from here, again, I happen to draw it to the origin, is positive at this point. So if it's positive, and I'm going to draw the original graph, f at x in blue, what does that mean our original graph is doing up until that point? It's increasing. So let's say we're down here somewhere. I'll try to draw a parallel with it. It's increasing. And then our graph does what? It hits 0 of our derivative. What does that mean for our original graph? F at 0. And f at 0, what's happening to the original graph? What's the slope at that point? If our derivative graph hits 0, it's 0. So in other words, it's a changing point. We have a horizontal. Okay? So our f at x at this point is horizontal. Now in our other graph, from here to here, from 0 to 3 it looks like, we're negative. And then again from 0 upwards we're positive. Okay? So we have critical points. Let's draw our critical points. I'm going to draw a straight line because we did talk about it. At 0 we have a critical point in our original graph. And at 3 we have another critical point. Let's zoom in a little. Okay. So we've drawn our critical points. What that means is our graph is going to be horizontal, the slopes of our original graph. Remember, we're drawing the original graph. Now, from 0 to 3, we have a negative. So if it's negative, our original graph is doing what? It's decreasing. So I have some graph, it's now decreasing. And then at 3, I hit a critical point, and I either start to decrease again or I increase. But I do have a horizontal here. So I'm going to try to emphasize these. Our graph is horizontal at these points. And then finally, because our f at x, our derivative is positive again, what does our graph start doing after that? If we're positive, our derivative is positive, our original graph is increasing or decreasing? Increasing. So then this goes on forever this way. So using the graph of our derivative, this parabola here, we're able to draw a rough sketch of our original f at x. We understand that when this is positive, this graph is increasing. When it hits 0, we have a critical point. When it's negative, this graph is decreasing. And then when this is positive again, the y values, this is increasing again. So this is what our original graph would look like, and this would what the derivative of that graph would look like. Okay? The numbers aren't to scale, we just are putting this graph somewhere. We don't know what the actual equation of it is.